Hello, we are from ChemPraxis, and in today's video we will be covering Physics Paper 3, Variant 3, October-November 2021, Question 2. In this experiment, we will be investigating the time taken for the filter papers to fall in air. Before we proceed, let's look at the apparatus first. So these are the apparatus that are provided for us for the setup. As you can see, we have the meter rule, the 30 cm ruler, 2 filter papers of different sizes, the stopwatch, the clamp, the boss, and the stand. Okay, so back to the question, we would now need to take one sheet of the smaller filter paper and measure its diameter. So now, we will use the 30 cm ruler to measure the diameter of the filter paper. Always remember, when measuring the diameter of anything, we will need to take the two measurements of the diameter at different points along the circle. And make sure we are measuring the maximum of the 2 points of the circle. So now that we have taken our measurements, we will need to take the average of the two diameter measurements we took to get our accurate D, which is 9.0 cm. Alright, let's proceed. Now we will need to calculate the area A of the filter paper. So we'll substitute the value in to get 63.6 cm squared. As we are using D, which is recorded in the previous question as two significant figures, hence we will round up A to 64 cm squared. Now for the next question, justify the number of significant figures that we have given for our value A. We can write D has two significant figures, hence A follows the number of significant figures of D. Now, we will need to set up the apparatus shown in figure 2.2. Then, we will need to hold the 6 sheets of smaller filter paper at the top of the meter ruler, and release the filter papers and start the stopwatch, and measure the time between release and the filter paper hitting the bench. So, we have our stopwatch here with us, and following the instructions given, we would hold the 6 sheets of smaller filter paper together as a stack on top of the meter ruler, and release it and simultaneously start and stop the stopwatch when it hits the bench. As you can see, the papers might separate during the fall. So, we can bend them slightly together so that they can reach the bench together. After repeating the experiment, we get the time of 0.66 seconds. So, back to our question. We can now record our readings. Remember, for time measurements in experiments, always take a second reading. For our time, we can take the average reading of 0.585 seconds. Always remember, for your raw measurements of time, we will need to follow to 2 decimal places as it is the smallest unit that our stopwatch can measure. Then, we can calculate the percentage of uncertainty in T. There are 2 ways to do this. We can use the half-range method, or we can use the absolute uncertainty of the measuring equipment, which is 0.2 to 0.5 seconds in this case. We will be using the half-range method this time, and we will get 5.1%. For the significant figures of your percentage uncertainty, we always follow the smallest SF of our substituted values. Now, we will need to measure and record the total mass M of the sheets of smaller filter papers, which I got as 3.5 grams. Make sure to write your units as the question did not include it. Now, moving to question C, we will need to repeat questions A1, A2 using one of the larger sheets of filter paper, and after that, using the 2 sheets of larger filter paper, we will also need to repeat the experiments in B1 and B2, which I have recorded the data here. For your area A, since we have recorded D as 15.0 cm, which is 3 significant figures, hence we will record our data as 177 cm squared. Moving on to question D, it is suggested that the relationship between T, M, and A is this equation, where K is a constant, and using our data, calculate the 2 values of K. So we will rearrange the question to where K is the subject, and we can substitute our values in, so we will get 383 and 753, which we will need to round it up to 2 significant figures, as it is the smallest significant figure of your substituted values. Units are not a requirement to be written in your answer, but you will not be penalized for it. Moving on to question D2, it is suggested that the percentage uncertainty in the values of K is 15%. Explain whether our results support the suggested relationship. So this is a very common question. We will need to calculate the percentage difference between our K values and compare with the percentage uncertainty given. So this is the formula of the percentage difference, which you will need to memorize. We will sub in our values, which we will get 65.1%, which is larger than the percentage uncertainty. Now we can write our conclusions. Remember, if your percentage difference is larger than your percentage uncertainty, then we do not support the relationship. If our percentage difference is smaller than the percentage uncertainty, then we support the relationship. Take note that it does not matter how large your percentage difference is, as long as it is larger than 0%. As long as you write the correct conclusions and calculations, you can get the full marks. So for this question, we can write, as the percentage difference is larger than the percentage uncertainty, hence results do not support the relationship. If your percentage difference is smaller than the percentage uncertainty, you can write, as the percentage difference is smaller than the percentage uncertainty, hence results supports the relationship. Now for our final question, which is finding 4 sources of uncertainty or limitations and their corresponding improvements. Always remember that for all the uncertainties that we need to identify are the ones that you will encounter when trying to take measurements. Now you may pause the video to think and write down the possible uncertainties and their improvements. Alright, now so for the first uncertainty and its improvements, you can always write this in any of your papers, so you need to memorize. So you can write, 2 readings of K are not enough to draw a valid conclusion. And its improvement is, take more readings and plot a graph. Or you can write, take more readings and compare K values. For the second uncertainty, you can write, paper not horizontal, paper too high to view against ruler, parallax in viewing start position, paper held by hand which moves, meter ruler not vertical. Always identify what is hard to measure first and include a reason. If not, you will not be awarded with marks. And for the improvement, you can write horizontal bar level with top of ruler, or use set square between bench and ruler, or use plumb line. You can always suggest a formula or directly draw a diagram to show how to get a more accurate measurement if you do not know how to describe them. For the third limitation, it is difficult to start stopwatch and release filter paper at the same time. And its improvements, you can suggest record a video with timer in view and playback frame by frame. For the fourth limitation, you can write problem with fall of filter paper, like paper does not fall vertically, erratic path, hits boss or stand, misses bench, paper separate while falling. And for the improvements, you can say use more filter papers, or use heavier or thicker paper, or glue them together, or switch off air conditioning, close windows, or use a windshield. Now there are 2 more additional uncertainties that we can write, which the fifth one is difficult to judge when to stop the stopwatch, as difficult to align head at bench level, papers arrive separately, and its improvements you can say use a pressure sensor below or position sensor above and below. For the sixth uncertainty, as the time we recorded is smaller than 1 second, which is very small, hence we can write times are small, so large error or uncertainty in T, or high percentage uncertainty in T. For the improvements, we can write use a greater distance to fall through, or use larger diameter or fewer or lighter or thinner papers to slow down the fall of the paper, hence increasing the time taken for the filter papers to hit the bench. So this is the end of the question. If you liked the video, don't forget to like, share and hit that subscribe button. This is ChemPraxis and thanks for watching.